Hello and welcome to the next D1 topic, okay? In this video, I always look at the board and think there's going to be something there, just lazy, just expect it to write itself. Pretty sure I'll invent that one day. Anyway, in this video, I'm just going to be, is it D1? It's not D1. Okay, well this was a complete and utter waste of time, so, thank you. Hello and welcome. This is a further Pure 1 FP1 video. In this video we're going to be looking at matrix simultaneous equations, okay? Basically solving simultaneous equations using matrices, okay? So when I say simultaneous equations, it is literally looks like a simultaneous equation you would have seen from GCSE, but obviously work it out in a different way. Because the video isn't labelled GCSE video. Okay, so the first equation that I've got, obviously I'm not going to use that one, just use a different one. I might start, shaking it up, mixing together, when at the end of the day it's simultaneous equations. Okay, so the first equation is 5x take 3y is equal to 7, okay? Equation 2 is 7x plus 2y is equal to 16. Okay. Now, naturally, what you would do in this situation is go, well, because they're both linear, and we will be just working with linear for this video. Okay. What you would do is rearrange whichever one you prefer. Okay. So I'm more likely going to rearrange equation 2 to get it just in terms of y. And then divide it all by 2 and sub it into this equation and get whatever x is, okay, and then work it out from that. But that's much too simple. Us in maths, we like to make things way too complicated than they need to be to make ourselves look like we're intelligent people, okay, which obviously we are. Okay, but in this video, we're going to be using, obviously, the last I said D1 in my last video, and I just completely went astray. FP1, sorry. In the last FP1 video, so label it on my forehead so I don't say it wrong. I'll still probably get it wrong. In the last video, what we looked at, we were looking at inverse matrices, and through that we looked at the identity matrix and the determinant of the matrix, okay? And we've not turned into another franchise of Matrix films. But anyway, we're going to be using some of that idea in working out this, okay? So, I just want to bring your attention to refresh your memory, okay, of a couple of equations that we learned in that video. Okay, these aren't given to you on your formula sheet. So, the inverse of A times A, or A times the inverse of A, is equal to the identity matrix, okay? We also said, sorry, no, that should be the other way around, doesn't really matter. The inverse of A times A is equal to the identity matrix. And we also, if you remember, the identity matrix, okay, was a 2 by 2 matrix, okay, so it's 1, 0, 0, 1. Okay, so binary speak. And we said that the in identity matrix times matrix A, okay, and I'll state what matrix A is in a minute, is equal just to the matrix A, okay? Is there any other? Oh yeah, obviously we have the equation for the the inverse matrix A, which is 1 over the determinant of A, which I can't really write down without writing, going into the previous video, but as I said, if you don't know what we mean by the determinant of A, please do check the previous video. And that was times by, I can't really go into this, times by B minus, sorry, I have to write out the matrix. So if we call the matrix A, we call it A, B, C, D, okay, then the inverse of A is 1 over the determinant of A, which is A times D, take B times C, or C times B, alright, so that's 1 over the answer of that, so 1 over the determinant of A, times, okay, so we switched A and D around, so it's D, and then B and C, we took the minus of them two, okay, it's minus B minus C. always remember to put your little commas, okay? Because you can quite easily turn any matrix just into a, from two column matrix into a single column matrix, okay? So I always like to keep the commas in there, just like this identity matrix up here. I mean, it's not so obvious here, but when you've got a negative, you could end up, easily just in heat the exam, turning it from a 2x2 matrix into a 2x1 or 1x2 matrix, okay? So don't get too confused about that. So really, I just want sort of introduce. So that's really said something that you should already know from the previous FP1 FP1 video that we did last time. Okay. Now the question obviously is, why am I telling you all of these different formulas? Well, the short answer to that question is that we're going to combine these two simultaneous equations into one matrix equation, okay? And what we're going to do is, basically, it will give us an unknown, two unknowns that we will have to find, okay? So, the best way of looking at this is really saying, well, that's not, in other words, that is 5x, but it's 5 times x. And the only way that we times matrices together is by doing column times row, okay? And if we've got column times row equals something and column times row equals something, they've both got x and both got y's, okay? And the y's obviously both are the second term, okay? And when we do column times row, okay, we do the first part of the first column times the first part of the first row of the other matrix, okay? And basically we add them together, okay? And in essence we've taken them away, but that's because we've got a negative here, okay? So when you obviously add a negative, you take it away. Okay, so hopefully that kind of made some sense. What I'm trying to do here is build it up, okay? So these two are coefficients of x and y, okay? The first coefficient is 5. And then the second coefficient of the first one is minus 3, okay? But 5 minus 3. But we need a 2x2 matrix on either side, okay? Because we need, when we're timesing two matrices together, okay, we need the same amount of numbers in a column, the second matrix, the same amount of numbers in the row, the first matrix, okay? So it's a 2x2 here, and it'll be a 2x1, sorry. 1x2, sorry, whichever one it is. Okay, so basically what we're having here is the 5 comes from the x coefficient of the first one, and minus 3 comes from the y coefficient of the first one as well. We'll worry about the 7 later on, okay? What we've got here is we need 5 times something gets us 5x, well that's obviously x, okay? And minus 3 times something gets us minus 3y, well quite clearly that's y. And similarly, because we've got x and y here, we're going to do the same method but just for the next row. So we apply the same thing we've done here just to this next equation, okay? So the first column is going to be to do with the x's, okay, and the second column is going to be to do with the y's. Okay, so 7 plus 7x, which is 7 there, and 2y, 2. Now you can quite clearly see I've put commas there. As I said, you don't have to, but it'd be quite understandable to see how you just switch the top to 2, and the bottom of the first matrix to 9, sorry. Okay, so we times it by x and y, and that gets us the answers, but we've got two different answers here. In the first equation we've got 7, and in the second equation we've got 16. Well, that will lead us on to the next bit, what I'm going to explain. Because the first part, the first row, okay, is to do with the first equation, okay? So the first row in this answer is going to be to do with the first equation, okay? So, therefore we put 7 on the top. And in the second row, okay, this is only a 1 column thick matrix, the answer, okay, because there's only 1 column thick matrix here. When we work out the second equation, we put that on the bottom, okay, the lower row, the second row even. So we'll put the answer to the answer to this on the second row of the answer matrix, okay, so 16. So that's essentially what we've got here, and we've got to find x and y out of that. Now if you were to do what you would normally do in that situation, which is times these two matrices together, what you would end up with is these two equations just there, and that's pointless because you're just going around in circles. So why the hell are you telling us this? Well, we need to do something with these formulas that, as I said, we'll learn in the last further pure 1 video. Okay, now let's just relate this idea to the equations I've put on the board there. Okay, so obviously I'm going to be rubbing this out, but it'd be a good idea to copy it down. So what we've got here is, that's just a matrix, okay? It's just a set of numbers. Okay, so we'll call that the matrix A, to relate to this. And the next matrix, xy, well, as I said, we know their numbers, but we're just going to leave it as xy because we don't know the true value of the numbers, and that's what we're trying to find out. And there's no point calling that A, because, you know, well, what can we do with that? And the answer to that is absolutely nothing, okay? So what we've got so far is A times xy is equal to the matrix 7, 16. Okay, so this is looking a bit more promising, but still, there's no point, there's nothing we can do from that yet that we couldn't already do with the previous matrix equation even, okay? So if we times both sides by the inverse matrix of A, I mean, we don't know what this matrix of A is, the inverse, but you could prove it does have it does have an inverse matrix because the determinant is not equal to 0 of this matrix over here, okay? But I'm hoping you just take there is an inverse of that. Okay, so anyway, we times both sides by the inverse matrix of A, okay? So if we do that, what we got is A times the inverse matrix of A times xy is equal to the inverse matrix of A times 7, 16. Okay? And we know from over here that the inverse matrix of A times A is equal to the identity matrix. Okay, so what we do here is we replace this by the identity matrix times xy is equal to the inverse matrix of A times 7, 16. Now, from this, we know that the inverse matrix of A times A is just A. But we got rid of A before, so why would we do that? Well, actually, this xy, that's a matrix on its own, but the only reason I haven't referred to that as our matrix A is because we don't know what x and y is. And if we did replace it with A, well, we'd just be left with 2 matrices that we called A, and what's the point in that? Now, as I said, I could have called it B, that would have avoided that, but where's the fun in that bit? Anyway, so we know that the inverse matrix, sorry, the identity matrix times the matrix A is just equal to the matrix A. Okay, so what I'm going to do is replace the the identity matrix, okay? I'm just going to almost cancel that out, okay? Because it's like times in xy matrix by 1. Sorry, just had to sort it out. Yeah, one of the people was outside and I was having to give him a good old swipe to the face. Anyway, apart from the death sentence and whatever I'm probably going to get thrown out with, let's continue with this. Okay, so we were talking about that the identity matrix times a matrix is just equal to the original matrix, okay? So, as I said, xy is essentially a matrix, but we've just not called it a matrix, okay, because, well, we don't know what the values are. Anyway, so that's just equal to xy. Matrix xy is equal to, well, this other part of the matrix hasn't changed. It's equal to the inverse matrix of A times 7, 16. Okay. Now, obviously we need to work out what the inverse matrix of A is. And remember, this original thing that we worked out here, 5 minus 3, 7, 2, okay, that is the matrix A. Okay, so to work out the inverse of matrix A, we use this other idea that we had over here and that we used in the previous video, which is why I've put all the rules on the board. Think ahead, don't I? Weirdly enough, it's like always like I've planned it out. Crazy as that. Okay, so anyway, the inverse matrix of A. Okay, so it's 1 over the determinant of A. Now, what is the determinant of A? Well, it's 5 times 2, take away 7 times minus 3. Oh, great. Well, that's not very good. Well, why? Oh, I can't believe this. I can't read what I'm writing down here. Is it? Oh, have I got the right answer? Sorry, I do apologise. No, don't listen to me. of mixing equations together again? No? Yeah, incorrect. Sorry, I do apologise. I thought I was, see I've got two questions here. And obviously they're both linear and they both start with 5x and 7x, but I've changed the other numbers. Because obviously, you know, I can't think for myself. And I thought I got the wrong. Anyway, everything's right. I'll shut up. Stop doubting myself. Anyway, the determinant of A is 5 times 2, take away 7 times minus 3. Okay? So if you do 5 times 2, take away minus 7 times minus 3, you'll obviously get 10 plus 21, which is obviously 31. Okay, so the determinant of A is equal to 31. So that's just a oh, sorry. Oh, wait. Oh, listen. Oh, God, what am I doing? I don't understand what I'm doing in my life. 7 times minus 3, sorry, it's the leading. Oh, is it? One sec. Yeah, determinant of A is 31. I just told myself to stop doubting myself and doubted myself straight away after saying that. Quite brilliant, this. Quite a skill, actually. Yeah, that's correct. Okay, so that's the determinant of A. Now what we need to do is rearrange this, okay? So it's the inverse of A is 1 over 31 times, okay, so we switch 5 and 2 around, so it becomes 2, 5. And we do the negative of 7 minus 3, but leaving them in the same position, so it goes 3 minus 7. Okay, so the matrix is 2, 7, 2 minus 7, 3, 5. Okay, we times that by 1 over 31 to get the inverse of the matrix A. Okay. Okay, so if you're to do that, well, there's no. It's just simplifying it down, so it's 2 over 31. Okay, and then minus 7 over 31, and then it's 3 over 31 and 5 over 31. Now you might simplify that down if you can. I think you can. But anyway, that would be the inverse matrix of A, which you would sub in, okay, to this equation over here and times it out like you would any other matrix equation. Okay, so xy is equal to, and we've just worked out the inverse matrix of A, which is 2 over 31 minus 7 over 31, 3 over 31 and 5 over 31. Okay, and we're timesing that by 716. Okay, so obviously what you do is you would do column 1 times row 1, column 2 times row 2, and column, so column 1 times row 1, and then column 1 times row 2. So what I'm saying by that is just if you don't understand what I'm doing when I'm explaining that, please do go and check out my multiplying matrix video, which should be up on the good old YouTube, which you're watching on, hopefully. It'll be in a playlist, which you can just go back and I give a bit of an explanation to what we mean by that. Okay, so basically this is column 1, so it's 7 times row 1, so it's 7 times, so you might want to split this up because x is the first, so x is basically equal to column 1 times row 1 and y is equal to column 1 times row 2. Okay, so x is equal, as I said, column 1 times row 1, okay, which is 2 over 31 times 7 plus 16 times 3 over 31. Okay, so x, as I said, is 2 over 31 times 7, okay, and then you add to that 16 times 3 over 31. And that should get you an x value of 2. Okay, so x should be 2. And then you do the same with y, but y is column 1 times, column 2 times row, what am I going on about? Column 1 times row 2. I do know what I'm talking about, just a bit wound head. So it's minus 7 over 31 times 7 plus 5 over 31 times 16. And when you simplify that down, you should get y to be equal to 1. Okay, so y is equal to 1, next is equal to 2. Now you could have quite easily just done that by using your standard GCSE rearranging skills of substitution or cancel or addition of them two, and working out x and y, and obviously you would get the same values. So that's just a tip really to finish off this video, as exciting as it is. When you've done this, okay, it might be a good idea, well it is a good idea, to use a normal method that you would have done way back in GCSE that you know works for simultaneous equations. I'm not saying you will definitely always get a question that is easy as that, but you can see definitely how it links in. Now there's one thing actually, so you can always go back and double check by rearranging these and finding x and y and making sure they're exactly what you found. Now, one more thing I just want to say. Now, in every question you won't have to show all this, okay? All the steps that we did before, in terms of, inverse of A times A is equal to the identity matrix. That's all just to help you understand where we're getting these terms from. But you can just, so this really says it all. Okay, so this step here, you don't need all of this crap, although it's a good idea to write it down. If you press you for time, just remember it. Okay, remember that xy, which is, if it ends up being in this kind of form, which it will be, okay, if you've got simultaneous equations like this, basically, x and y is equal to the inverse of a, which obviously you'd have to work out, times, we put 7/16, so the answer to the first equation in the top part of the matrix, and then the answer to the second equation in the second row of the matrix, which you times in the inverse of a. Okay, and that'll get your answers to x and y respectively, x being the first column in the answer matrix and the second, y being the second column in the answer, second row in the answer matrix, okay? So, hopefully you understand that, but, it's a good idea to show all this working, but you don't necessarily have to if you just go straight to that, okay? Really, as I said, that was just to get your idea flowing. Really, I'm not going to do, I was going to do some extra questions if I completely messed that up, but seeing as I'm lazy, and I think I've done a good enough job on that, more to the point, I can't be bothered doing anything else. Says it all really, doesn't it? Probably should be a little bit bothered. Anyway, actually, just one more thing before I go. There is, so kind of giving you an idea of what just to do. But what I've got here is I've got a method, a model method, we can call it that, if you're going to work through the whole thing in your answers. Okay, so the first step is to put it into a matrix equation. Okay, so the coefficients of x and y, so in column 1, you would put the coefficients of the x, the first equation, and in the second row, okay, the first column, the second row of the first column, you'd put the x coefficient of the second equation, okay, and then you would put the y coefficients in column 2 of the matrix which you times it by, and then you times that whole matrix by the matrix xy, and that's equal to the answer of your first matrix in the first row, and the answer to that is equal to the answer of the first simultaneous equation, okay, at the in the first row, okay, the column of the answer matrix, and in the second row of the answer matrix you put that is equal in the second equation, okay. So when you've done that, you will rearrange like we've done here to get xy is equal to the inverse of the matrix A times, in this case 7/16, which is the answer to the first matrix, and then the answer to the second matrix, okay. And then you times it, and then obviously you work out the inverse of matrix A, and in other words you solve to find x and y. So that's kind of a quick method to learn, to be able to understand that. But hopefully, as I said, there's not that much extra time you would spend showing all your working for that if you can remember it. And it kind of helps you to know where you're going. But, as I said, you can just work from the xy is equal to the inverse of matrix A times the answer to the first matrix over, the answer to the first simultaneous equation, the first row, and the answer to the second simultaneous equation in the second row. And you determine which is first and second, okay, which I keep referring to that. Whichever you put, so when in this matrix here, that I'm times by xy, whatever you put in the first row, so the coefficients, as I said, the first coefficient of the x, the first equation, and the the coefficient of y, the first equation, if you put that in the whatever coefficients they're from that you put in the first row, which is times by xy, okay, to get the answer, that's your simultaneous equation 1. Okay, so hopefully, as I said, try to get that out in the opener. Okay, but yeah, if you have any issues with this question, please do just drop a line in the comments below, or you can go on my Facebook page, which is Build7187 Facebook page, and email me through that. Okay, or whatever these fancy technomobile kids are doing these days. Damn them and such. Okay, so thanks for watching, and we'll see you in the next video, hopefully.